So this is the second example, the second scenario we're looking at. We've got a memory test with 10 objects. So maybe you're shown 10 objects on a tray. I think this used to happen on the Generation game. Remember the conveyor belt on the Generation game? Or was that just before your time? And you had to remember what was on there. And you had to say, cuddly toy. There's always a cuddly toy on it. And there are things like fondue sets, which in the 1970s were just amazing, and tea makers and things like that.
And that spinning the wheels.
I think spinning the wheel's a different one. But anyway, it might have been. I have to say, my knowledge of the Generation game isn't complete and brilliant. Not at the moment. Example number 2. Memory test. 10 objects are shown to you for a period of time, then maybe they're hidden or removed, and you've got to say how many of them you can remember. Now, historically, okay, when people have been doing this, there has been a success rate which averages at 35%. So that means, on average, people manage to get 35% of the objects remembered.
Well, I thought it meant 35% of people remember all 10.
No, okay, that says basically on average people remember 35% of the objects. Okay? Now, what is happening now is there's this new energy drink called Red Cow in the market, which is supposed to boost people's mental performance. Okay? And people are now given this drink or whatever it is, and then they are asked to do this test. So they do the test.
Will it be the same object?
It would be, yes, everything in the test is the same. The test is the same. So the question I'm asking you is this. What would the success rate have to be to show evidence?
Does it say best or test?
Test, it should say. What should the success rate have to be to show... where are you asking about, Billy? Here.
Energy drink, best or test?
That's supposed to say test there, sorry. They're having energy, then they're taking the test. Energy drink, then they're taking the test. What would the success rate have to be to show evidence that the energy drink improved people's results? Improved performance, shall we say.
We still need to do H0 and H1.
Yes, we will still have to do all that sort of stuff. Okay. So, again, the first thing I think I asked last time when we looked at this was, I said, does this look as if it is any distribution we have come across so far? Now, the fact that we are doing at the moment discrete hypothesis testing means, well, you only know about 2, the binomial and the Poisson. But remember, in the exam, it won't be labelled up, by the way, this is testing you in discrete hypothesis testing. But you need to realise that, you know, this is a discrete one. So is it binomial or is it Poisson? It is binomial here that we're looking at. A fixed number of trials. So, again, here we have fixed number of trials. We have that under the null hypothesis, historically, there's a constant success rate. So, historically, constant success rate, that's telling us that P is 0.35. The fixed number of trials, that's telling us that the N is 10. And what we're after here, what we want to know is what our critical value is. And you can think of that really as our R value that we are after if we are going binomial. So we'll say X is the number of items remembered, and the X at the moment is binomial 10, 0.35.
What is the significance level?
We'll use 5%, okay? So, we'll use 5%, we weren't told, so we'll use 5% significance level.
Should you always be doing that?
They'll say in the exam.
Oh.
But it's a generally used one, most scenarios use 5%. Mind you, if I was spending lots of money, I would want a much smaller level there before I invested lots of money, because it'd be a 5% chance that it was all a fluke. I wouldn't want to invest lots of money if there's a 5% chance that it could all have been a fluke and my pill's rubbish. What we are going to look at in the next chapter is looking at what happens when you change the significance levels, what risks and what benefits does that have. So that comes in the final chapter. Okay, so H0 here is to do with P. H0, historically, P is 0.35. What we want to know now for H1 is... yeah, okay. My notes here I've actually got, I wrote it down differently, is it just changed? But no, we'll go for improved performance. So then P is greater than 0.35. Actually, can we change it to P not equal 0.35?
Yeah.
And can we go back and change up here to has the energy drink changed performance? Because we haven't done a two-tail one yet, and I would like to do a two-tail one. So we'll change that up there if you don't mind. Has the energy drink changed the performance? So we do have experience of doing a two-tailed test.
It could make you really stupid, that energy drink.
It could make you really stupid, yeah. You don't really want to market your drink. Have this new drink called Red Cow. It makes you really stupid. Imagine that as a strap line. Who would go and buy it? Really stupid people, I guess. Right, okay, so what we've got here is a two-tailed test. Now, I'm going to draw a graph, effectively now, of what we have got here. We've got here X, and up here we've got probabilities. And what we are going to have here is probability bars. Whether I can get... How many... I need 11 bars here altogether, wouldn't I? I just might have a sort of dot somewhere. I don't know exactly what shape they are. I'm going to put a sort of dot there. But I could have from 0 to 10. Okay? So I've got sort of bars like that. Now, if it's a two-tail test at 5% significance level... Now, I don't know where these lines... I'm just going to draw lines on here. I don't know where they actually will be. I haven't done that yet. But what I'm looking at is there'll be a line here, and it might go through a bar. It probably will go through a bar. And a line here where over here there's 2.5%, and over here there is 2.5%. Now, before we actually go ahead and do anything, this next bit is quite important. Let's assume I've got my lines in exactly the right place, going through the 9 bar and going through the 0 bar.
That's the 1 bar.
Sorry, the 1 bar, thank you. What would be my critical values to tell me that my drink has had an impact? How many, remembering how many items?
1
Here, the 1 bar, some of the probability in the 1 bar is not in the critical area. So if somebody scored 1, for example, you don't know actually that is one of these very small results in the tail or not, because they could have come from that part of the 1 bar to the right of the line, which isn't in the tail. So actually, if my line is in the right place here, we would reject H0 for a 0, but not for a 1. Because if it's a 1, we don't know whether it's come from the left-hand side of the line or the right-hand side of the line. And over here, likewise, if we got a 9, because some of the probability for the 9 is not in the tail, only some of it is, we couldn't actually accept... We couldn't say that we would reject H0 if we got 9. We would only have to do it if we got 10. That becomes important later on. But I don't know. Those green lines were just drawn in sort of random places at the moment just to demonstrate a point. What we're going to do now is do the calculations and see what we actually get.
So if you drew a line and found it was going through, like, most of 1 was outside, but only a tiny bit was in, sort of, the 1 with 1.
You still have to reject it,
right.
But you still have to not use it. I won't use the word reject. Not use it in your critical region, because the result you got could be the bit that is not in the critical region.
Like a possibility that it wasn't.
You still say no, can't conclude. So,
what if it was in 0 and 10?
If it was in 0 and 10, then you probably need to have more
significant.
Well, or just do it more times to get something like that. Okay. Right. So here we go. This critical region over here, we are trying to find two critical. If I label that one there, and it's C1, critical value 1, and that there, critical value 2, we want to find the probability that x is less than C1 has to be smaller than 2.5%, and we have to find the probability that x is greater than C2 to be also less than 2.5%. So in the scenario we're doing now, we are going to use binomial tables. Now you may be able to do this on a calculator by doing an inverse one on a calculator. I'll leave that up to you to find out whether you can do that easily. Binomial tables, here we're dealing with n is 10, p is 0.35. Now I've got a note here that in the S2 books, if you're using tables from the S2 books, they've printed the 0.35 and the 1/3 columns the wrong way round in the textbooks. In the textbooks, apparently on page 162, they have printed 2 columns the wrong way round. In the formula book, you're okay. So if you're using a formula book, and I've got here formula book should be page 11, then we should be okay. So I reckon we are looking for x values and probability. Well, what are we finding? What
So is that
is
1/3 and 0.5 for the whole table?
no, and just in that one, just on page 162, I think of the textbook I've got a note. And if you look at it, the numbers you can see because the numbers, instead of following a pattern as you go along, there's a little peak in it. But if you use the green formula books, they're fine, they're accurate. So what we are looking for, first of all, is the biggest probability we can find, which is greater than 0.025. So what you're looking for is the biggest probability that's less than 0.025. What's the biggest probability you can find that is less than 0.025? Smaller than 0.025 in that column.
0.0135.
I'm agreeing with what Chelsea said. 0.0135, which belongs to an x value of 0. Okay. Then what you're looking for, the second time, is you're looking for the smallest probability, which is greater than 0.975, which is up at the other end, which is corresponding to this one here. So you're looking for the smallest probability that's bigger than 0.975. What is that?
1.
Not what I've got down here. 0.9952, yeah, which corresponds to an x value of
7.
7. Yes. Okay. So, well, I'm going to do a little sketch here again of the sort of graph. What I've got here is I know that the 0 bar, I know that the probability, I'm going to put a 1 bar in here as well. I know that the 0 bar, if I put a line in here, to the left of that, I know that that is 0.0135. And I know that the 0.025 is somewhere here in this bar, because the one number is more than that, because that's included all of that. So the 0 is critical region. The 1 is not. And then if I put sort of my dot up here, I've got a 7 bar, an 8 bar, a 9 bar and a 10 bar. You've just told me that the probability of being less than or equal to 7 here, being left of there, is 0.9952. What does that tell you about being right of there. If you take that away from 1, what does that tell you about being right off there? Okay, so sorry, that line would have been somewhere in the 7. Sorry, I ought to put that line somewhere in through the 7. Sorry, somewhere through the 7, not after the 7. Sorry.
I do know somewhere through the 7.
Because if it had been exactly at the end of 7, you would have found in the tables 0.975. You didn't find 0.975 exactly in the table. You looked for this number here, which was the number, which was the smallest number bigger than it. The important thing is that this here, these values here, are your critical region. It's like coming back to when we had that last example, particularly the upper end, that 7 is like your C minus 1. If you go back to the last example we had here, the big end, where the numbers are big, that is like your C minus 1. And here we had to add 1 on to get where our critical region started.
Yeah.
You have to do the same thing here. That table gave you 7. At the big end, where the numbers are big, you have to add 1 on, so the critical region here will be after the 7, because some of that 7 is in it and some of the 7 is not in it. So the critical region is 8 up at that end. So what we are going to get here are the critical values are 0, 8, 9 and 10. So only if people were remembering 0 items or 8, 9 or 10 items after the drink would we be accepting that the drink had made a difference. I'm going to stop the video there.